We're going to go over examples on page 2 of your Unit 7 packet on how to now work with the equation that we derived in the previous video. So the equation that it does say you must memorize is x minus h squared plus y minus k squared equals r squared, where hk is your center and r is your radius. Okay, so hk is a value. Notice that when you plug hk in, the minus sign here would indicate that these are opposite in signs when you are pulling out the values of the center. So we're first going to start with, I'm going to actually start with number 3, 4, 5, and then go back to 1 and 2. So 3, 4, 5, you're given the equation of a circle. Now if we see x without anything subtracted to it, or y without anything subtracted, I should say, from it, then the center is 0, 0. So if you subtract 0, it's not going to impact the x value at all. So what we do is we substitute x minus 0 as just x squared, y squared. So when we see an equation written like that, we assume our center is the origin, 0, 0. The radius is always going to be the square root of that value there. So in this case, 3. So if they asked me to graph the circle, I would need the center and I would need the radius. So the center you plot at 0, 0, the radius being 3. You would go right 3, left 3, up and down 3 away from the center, and get the equation of your circle. Okay, now the next equation, you see that you do have a value, and because the equation that we learned is x minus h squared plus y minus k squared equals r squared, we want to make sure when we take out the center that it's the opposite in value of positive 2. So negative 2, opposite of negative 1 is positive 1. The r value is the square root of 9, which is 3. So you always plot your center first, so negative 2, positive 1. And from that point, you go right 3, you go left 3, up 3, down 3. And sketch your circle based off of those 5 points. Okay, why don't you guys hit pause and then try number 5 and check your answer. All right, so your center, there is no change in x, so 0. And then change of y is going to be opposite of positive 1, negative 1. So 0, 0, negative 1 would put us down on the y-axis there. Positive 4 would be the square root of 16, so our radius is 4. So plus 4 to the right, left 4, down 4, and then on top 4, 2, 4. And then sketch our circle through, we should get that as our circle. All right, so now going back to, and I'm going to make some space here, going back to the first 2 examples where they asked us to write the equation of each circle. They want the standard equation of a line, of a circle, which is your x minus h squared plus y minus k squared. So here we have that the center is 0, 0. So we're working backwards here, not graphing, but writing the equation of, and the radius is 6. Why don't you guys hit pause and see if you guys can figure that out. Okay, so there was no change in x squared. There was no change in y squared, and then r squared is 6 squared. So if I simplify that out, x squared plus y squared equals 36. Now D, the second question, D, that passes through 1, negative 2 with center 3, 3. Okay, so this time it just says, I think it's supposed to be circle D, passes through a coordinate point 1, negative 2. So what I'd like to do is sketch this for you so you can have an idea of what we're dealing with here. 1, negative 2, and the center is 3, 3. Okay, so if it passes through, so if this is my center and it passes through here, I can see that what I have is a circle with an arc that goes something like that. Now, the radius is the distance between this point and this point. So I can't simply just count, that line is at a tilt. So if you remember back to first semester, if I want to find the distance between those, I'm going to use the distance formula, similar to that exploration we did on the other page. So R is equal to distance formula, x2 minus x1 squared plus y2 minus y1 squared. So, and then the square root of all of that. So 3 minus 1 squared plus 3 minus a negative 2 squared. If I simplify that out, I have 3 minus 1 is 2. 2 squared is 4. 3 plus 2 is 5 because of the double negative. And then 5 squared is 25. So square root of 29 is equal to my radius. So when I write my equation, I'm going to need my HK, which is my center, and then my radius is radical 29. So I'm going to write it above as my answer. Let's go ahead and start with x, and it really doesn't matter the order here, but I think we've been working with x first, so let's go ahead and start with x minus 3 quantity squared plus y minus 3 quantity squared. And again, I get those values from my HK equals radical 29. What did I forget? That's squared, right? So my final answer, x minus 3 squared plus y minus 3 squared equals 29. So just to answer 6 and 7 with you guys here, it asks me to describe the transformation that occurred from problem 3 to problem 4. So it looks like we took the circle, and since the radius is the same for both circles, is the same size, what happened was that we shifted the circle, and you can use the center as a bearing to figure out where it is that you moved. But it looks like we went left 2 and then up 1. So left 2, up 1. Notice the signs that are associated with left 2, up 1 also reflect the values of h and k. Describe the transformation from problem 3 to problem 5. Okay, so from problem 3 to problem 5, the center did shift. So we went down 1, and again, notice the association with positive 1, down 1. And then it also was dilated. In this case, the dilation is an enlargement, and then the factor in which it got enlarged was the radius went from, so there's a dilation, and your radius went from, so radius to radius, if you compared it, it went